Graphing circles. What we're going to do now is look at how do we graph a circle on the coordinate grid? And maybe more importantly, how do we write an equation so that we could graph a circle on the coordinate grid? Remember, by definition, a circle is a collection of all the points that are equidistant from a common point called the center. And if we take that definition and we think about a circle on the coordinate grid, there's really two things that we need to know. We need to know the center and we need to know the radius. Because if you have the center, you can figure out where you want to start drawing your picture. And then if you have your radius, you can measure out that distance in all directions and actually draw the circle. Okay, for simplicity, what we're going to do is just start with a circle that would be centered at the origin. That way we don't really need to deal with the actual location of this so much. We can just let it be at 0, 0. Okay, so I'm going to build a circle around the origin. All right, so a circle centered at the origin. It is a collection of an infinite number of points that are all equidistant from that center. The distance out would be measured as the radius. Okay, so what I'm going to do is choose one point just by random. Just suggest that there's a point that's here. That point does have a coordinate, which would be an x, y coordinate. The distance out to that point from the center is what we call the radius. All right, so the idea of an equation that would apply to the coordinate system is that it builds a relationship between x's and y's. Whatever other things that you need, whether you need to square things or add a certain value to it, or whatever the case is, you're building a relationship between x and y, which will typically say y equals something involving x. In this case, it's going to be a little bit different than that, but we are still going to build a relationship about x and y. The only other aspect of the circle, though, that's important is going to be the radius. So ultimately, what we're going to do is build a relationship between x, y, and r. And to do that, surprisingly, what you're going to need is a triangle. To write the equation of a circle, you're actually going to need to use a triangle. And it looks like this. Given any point along the edge of the circle, you can build a triangle. But not any type of a triangle. It would be a right triangle that you can build. Okay? The distance straight out to that point will be a hypotenuse. The other two measurements would be leg lengths. And those leg lengths are going to correspond to whatever these values are. Because if you think about how to plot a point, how we get out to here, you'd move an x amount left to right, and then you'd move a y amount up and down. So this right here, that's a length of x. And vertically from there is a length of y. So altogether, we can build a relationship using these three letters, which is actually Pythagorean theorem. We can say that x squared plus y squared is equal to r squared. And that is the equation of a circle that is centered at the origin. That's the catch there. That is the equation of a circle that is centered at the origin with a radius of r. It is literally based off of Pythagorean theorem. So if you want to center the circle at a different location, all you really need to do is tweak this equation a little bit. Suppose that we want the center to be at a location called HK. The equation would look like this. In parentheses, you would take x, subtract the h, then square. You'll still have the addition. In parentheses, you're going to have y minus k squared. And that will still equal the radius squared. Okay, so it is still based in Pythagorean theorem. All we do is we directly subtract the h from the x and subtract the k from the y. Okay, the reason that this works out is going to be a little bit too difficult to discuss now because this comes from ideas that you learn in Algebra 2. But generally speaking, if you want to shift some sort of a graph left or right, and that's what the h would do here. It would move the graph left or right because it places the center left or right with that x value. If you want to do that, then you need to apply that value directly to the x before anything else happens like the squaring. Same thing for the k. The weird thing here, though, is that the way that you see the values, if h is a positive, which means you'd be moving to the right somewhere, you need to show it as subtracting, which might make you think that you're moving to the left. Everything appears to be its opposite when you apply it directly to the x's and y's. Same thing with the k value. If the k value is positive, which would mean that the circle is pushed upward, what you're actually going to do is show subtraction. If this is an addition here, that tells us that the circle is moving down. If this is an addition, it tells us that the circle is moving left. So overall, what it means is that what you see in the equation, whatever values you see after the x and the y, think of those as their opposites to figure out where the center is. Or if you're given a center, just make sure that they go into the equation appearing as their opposites. For example 1, let's go ahead and apply our formula to graph this circle. A circle on the coordinate grid is going to be defined by two things. First, where is it located? Which for the most part you can get from the center of the circle. The second is how big is it? Which you get from the radius. Okay, so the center for this circle is going to be taken from these two values, which would be your h's and k's. But it's important that you see them as their opposites from what is printed. Okay, so that would be a -2, but you're going to take that as a 2. For the center, the x value is going to be a 2. For the +1, you're going to take that as a -1. So the center is at 2, -1, which is here. The 25 is going to give us the radius. The radius here is going to be the square root of 25, which is 5. All right, so then given these two pieces, we can sketch a picture of the circle. The best use of the coordinate grid that we have here would be to count the radius up, down, right, and left. Okay, so 5 units up will take us to this point. So that will be on the circle. You could go 5 units out that direction. That would be on the circle. Go 5 down here, and then 5 to the left. Then we'd have a circle that goes through those points. All right, so rather than sketching this, which probably won't look that great, I'm going to go ahead and use a compass here. Okay, I'll get it centered right there. Go ahead and measure this out to a point. Just do a quick check to see if it, yeah, it should match up pretty good here. All right, and that is our circle.
Wait, what?